We'll be discussing the ambiguous case of the law of sine. So let's get started. Let's start by looking at this diagram here. So we have a diagram and we're stating certain lengths. So we're saying that AB has a length of 12. And now suppose that it's a line segment BC, which is attached to point B. So we're going to be creating a line segment BC where pretty much we're going to be defining our point C in different places in our diagram. But the only condition is that BC, or this line segment that we're about to create, is going to have a length, which we're going to call K. Now we want to find, or we want to define K in such a way that AB, BC, and line M form different triangles. So what do we mean by all this? Well, here notice that we almost have a triangle. We're just missing one side. So you can think about this as being the base of the triangle, one leg of the triangle, and the other leg of the triangle is going to be defined by line segment BC. But notice that the way that we define this line segment BC can determine how many triangles we can actually get. But before we start creating triangles, let's define the height of this triangle. So whatever triangle that we're going to be creating, it must have some kind of a height. So let's, right here in red, let's define the height of my triangle. And now let's start looking, where can we exactly define this new line segment BC in such a way that we have 0 triangles. So let's take a look at the case where we have 0 triangles. So when can we have 0 triangles? Well, if we define our line segment, I don't know, let's define our C here. So notice that now we're defining BC and we're saying that BC has a length of K. Notice that we define BC this short. If BC is shorter than the height of K, notice we just don't have a triangle here. So this will be the base, this will be the leg, and this will be the other leg, and we cannot complete this triangle here. So it is true that we have a third side, but notice that the side is shorter than the height, so therefore we cannot even close the figure and we cannot create a triangle. So we can have situations where we can have no triangles whatsoever. And one of the situations is that if this line segment BC, which again we're going to call it K, if this K is less than the height, if K is defined as something shorter than the height, then we just cannot create a triangle. So therefore, we can define a third side, but if that third side is definitely shorter than the height, then we just can't create a triangle, even though we are defining a third side. But we could also have situations where we create one triangle. So let me actually change color for that. 1 second, let me get my eraser. So now, when exactly can we have one triangle? Well, there's 2 ways that we can define one triangle, still using the same diagram. Same base, same length of 12, same height. We can create one triangle if this line segment BC, it's exactly the height of the triangle. So we can have a situation where if this line segment K is equivalent to the height, which again, K is equal to height, then we can definitely define one triangle. And notice that here we have it. Here we have one triangle. So this is one way that we can define one triangle. If this new line segment K or BC is the same length as H, but notice that we can also have another situation where we have the same conclusion. So what's another way that we could define that third line segment in such a way that we only have one triangle created? Well, we could have also had a situation where perhaps, and again, notice that here I'm just creating a new third side. Let me define here Z. and here my k. Notice that I could also have the situation if k happens to be greater than 12, then we could also just define exactly one triangle. Why? Well, let's think about it this way. Let me actually pull my figure out a little bit higher. Uh, so why exactly, if this line segment k is something that is greater than 12, why is it that we could only create one line segment given this length? Well, I guess let's assume that this is 16. So if k has a length of 16, notice that if we think about this as if it was some kind of a circle, okay, so think about this as being the radius of a circle. If we go around, this figure, and again, I don't think this is going to be a perfect circle, so you're going to have to excuse me for that. If we go around this figure, notice that it's only going to be touching the base of the triangle exactly at this point, because if I know that this is 16, notice that as I'm moving along this edge of a circle, it's just not gonna even be touching here because I know that this is 16 and I know that this is 12, so there must be some space here. And if I keep going around this figure, and again, I don't think this is going to be drawn to scale, but if I keep going around and around, and again, imagine that that's just the radius of a circle, this point C, it's only going to be touching the base of the triangle exactly at this point and nowhere else. Because if I keep going around, that C is just going to be touching the base of the triangle at this point and this point only. So therefore, if this third side it's greater than the other leg, which in this case 12, then we can only have, or we could only create it exactly one triangle. So we could also have one triangle if k is pretty much greater than the given side. So notice that we could have two situations, because again, we're just defining this third line segment in such a way that we could have created different triangles. So we already saw the situation where we could create 0 triangles. So if this length is definitely less than the height, and there's two possible ways that we could create exactly one triangle. If this third side is exactly the same length as the height, or if this third side is greater than the given side. So are these the only two possible situations that we could encounter? Well, not exactly. For this, let me actually erase my diagram. All right, so we're back. So what would have happened if this third line segment, which let me use a different color instead of orange, what would have happened if this third line segment is actually less than 12? So what would have happened if we create a line segment, let me call it C, in such a way that k, or this value, or this length, is actually less than the given, which is 12. So what would happen if we have that scenario? Well, again, think about it as this being some kind of a radius of the circle. So let's go around in circles. Let's go around in a circle. So if that's the case, then notice that there's, and again, I guess ignore these 2 points. I feel like I'm already going bad. If that's the case, notice that since k is less than 12, so therefore there must be a point within this segment that point C is still going to be touching somewhere else in point M. So notice that we could have called this C2. And notice that this length that we are creating here, is actually the same as value of k. So we could have created two different triangles within the same condition. Again, if we were to go around in a pendulum, notice if we go around a pendulum, there are two possible locations where this C can be defined. one of them where we initially did it. But if we go around it, notice that there's going to be a point somewhere in this line where C is still going to be touching line M in such a way that this K is also defined the same way that we did it over here. So we could have two different triangles. We could have a very short triangle, which notice that we're not changing anything. We still have angle A, and we still have line segment 12, and we have line segment K, and also we could have a different triangle where it is still angle A, it is still B, it is still C, and notice that this is still K. So notice that there are two possible triangles that we could have gotten, which still A, still the same angle, still the same length of 12, and is still the same length of K. So there can be cases where perhaps we've been given the same condition, same value of A, same length of 12, same length of K, where we could have created two different triangles still using the same information. And that is what we call the ambiguous case of the law of sine. So we could also have two conditions. We could also create two triangles. And that is true whenever for first, this K needs to be greater than the height. Because if this K is less than the height, we already show that there is no triangle. But also at the same time, it must be less than the given. If K is greater than the height, and if K is greater than the height and also less than the given. So we could have a different situation. This is what we refer to as the ambiguous case of the law of sine. So even though you've been given the same situation, the measurement of an angle and the measurement of two sides, there can be cases where perhaps we can create two completely different triangles given the same measurements of an angle, a side, and a side. So is it possible for us to create three different triangles given the same conditions? Well, in this case, it's just not possible. It's just not possible. So when we're talking about the creation of triangles, we have to keep in mind that we could encounter three different situations. We could have created no triangles, we could have created one triangle, or we could have created two different triangles. And again, notice that the way that this information is given to us, this information is always given to us in the terms of side, side angle, side, side angle, side, side angle. So remember from our previous lesson that we stated that we cannot use side, side angle to define or to show congruency among triangles. And this is the reason why, because it's obvious that these two triangles are not congruent, even though they have the same condition, same angle A, same length of 12, and same length of K. Two different triangles, it is just not enough, or it is just not true that these two triangles are congruent to each other. So just to summarize, we could have different situations here. We could have the situation where we have zero triangles. So let me get the same color. We could have the situation where we have zero triangles, and we could have created zero triangles if and again, notice that I'm trying to do the same problem. I'm just going to try to summarize this. If we've been given a length of 12, we could have zero triangles if this third side is less than the height. So if k is less than the height, then we cannot create any triangles whatsoever, because notice that we're missing all this. So we could have situations where we create no triangles. We also state that there were situations that we could have created just one triangle, and we said that there were two possible ways to go about it. The first situation that we could have created one triangle is if we let, let's define the height again. There's two different situations that we could have defined just one triangle, and that is if we let our k to be exactly the same height. So if k is exactly the height, then we could have created one triangle. Or also, we could have also created just one triangle if okay. There, make it a little bit faster here. Okay, so we're back. We could also create one triangle if this third side that we're missing, it's something greater if k is greater than 12. Because again, we said that if that is true, then if we go in circles, okay, very bad circle, but I hope you kind of understand what I'm trying to say here. If we go in a full circle, there's going to be just only one place that we can hit this line which we defined initially. So these are the two possible ways that we could have created one triangle, if the height is equivalent to the third side, or if the third side or the other leg it's greater than the given. And we stated that we also have situations that we could have created two triangles. And we said that there's only one way that we can create two triangles, and that is if in any given triangle, if we let the third side, if we let the third side, hold on, let me draw my height. If we let the third side be less than, if we let k to be less than the given side, which in this case is 12, notice that if we go around in circles, notice that this point right here, which let me call it C2, this line right here, it's also the same height. I'm sorry, it's also the same length k. So we could have created two possible triangles. One being very small, like this. So A is still 12 and is still k. And also, we could have another bigger triangle, which is still, notice that it's still using the same angle A. Notice that we're still using the same length of 12, and we're using the same length of k. So notice that these two triangles have the same information on it. The same angle A, the same side 12, and the same side who has length k. So this is what we refer to as the ambiguous case of the law of sine. On the next video, we're going to be working on some examples to demonstrate when do we use this law.